What's good, code milkers? Today, the problem was product of array except self. This is a problem I'd already done before, so it didn't make sense for me to do it again because I'd done it pretty recently. It was like 2 days ago. So it was so fresh in my mind, it didn't make sense to do a live coding challenge of it. Instead, I went with refactoring my original solution. So for a few hours, I just researched better solutions and just figured out how to optimize the original solution and get the time complexity better. Because the original solution wasn't optimal by any means. It beat 15% of JavaScript submissions, which is like barely passing. So the new one beats like 80%, in the range of 75 to 95%. So it's a pretty good solution. I have the original solution here. It's a little wordy and it's not that good, so I'm not going to bother explaining it. So I'm just going to comment that out for now. Actually, I'll just get rid of it for now, and I'll put it back at the end of the video. I'll just explain the better solution instead. So first, let's look at the problem itself. Problem is product of array except self. Given an array nums of n integers where n is greater than 1, so the nums array will always have at least 2 elements in it, return an array output such that output at the given index is equal to the product of all the elements of nums except nums at the same index. So the word except is kind of confusing in this context if we don't look at the example. So let's look at the example. So they give us an input of 1, 2, 3, and 4. And the return value is an array with 24, 12, 8, and 6. So let's break this down, and why are we decreasing in numbers for this input that wasn't in ascending order to begin with? So if we look at the number 24, let's try to reverse engineer how they got that answer. So if we look at the element, so we're at the 0th index of output. If we look at the 0th index of the input, we have 1. So the product of the array except self doesn't include the current indexed element. So 1 is not included in the product. We do include, however, the rest of the array. So 2, 3, and 4. So 2 times 3 times 4 is 24. For the next element, 12, the same indexed element here is 2 in the input. So we leave that one out. So we have 1 times 3 times 4, 12. Then we have 8 and 6, and the same pattern works for them too. So the real question is, how can we solve this without division and in linear time? Now, I'm not sure this new solution I made is linear time either, because I have to go through the nums length twice, which makes it 2 times n technically. So I'm not sure why all these solutions say linear time, because I don't see how they are, since they require going through the input array twice, or at least the length of it twice. But I'll go through a drawing of how I made this new solution. So if we have 1, 2, 3, and 4, if we look at a given element, so say we'll start with 1. If we look at that element, the product is going to be all of the numbers multiplied in this subarray. And if we look for the next one, for 2, it's going to be the non-contiguous subarray of 1 and 3 and 4. 3 is the same shape as this, but reversed, so it's 1, 2, and 4. And then for the last one, for 4, it's the 1, 2, and 3. So basically, if we want to break down this problem linearly, like moving across the array in one direction and then moving back in the other direction, we can think of it as finding in the first pass the accumulated product moving from left to right, not including the current element. And then on the pass back from right to left, of the accumulating product from right to left. So if we have 1, 2, 3, and 4, let's have our output here. We're going to make it an array with the same amount of space. Then we start at 1. Now we set the first element of output equal to the current element, so 1. Then we have an accumulator that starts at 1, and we multiply this by the element at the current index of nums. So we have 1 times 1 equals 1. So the accumulator for the next element is going to be 1. Next we do, we take the next element of output is equal to the accumulator again. So it's 1, but now the accumulator is multiplied by the next element of nums. So it's 1 times 2. That looks like division. It's 2. Next we have 3. So the we insert the accumulator here, 2, and then we multiply it by 3, which gives us 6. And lastly, we insert 6 here, and accumulator resets to 1 for the pass back, because we're at the end of the array. Now we're going to go backwards. So cross this out. So we're starting at 1 again. So 1. On the pass back, we're not we're reassigning the elements, but we're multiplying. So we're multiplying the element at output I by the current accumulator. So the first one will be 6 times 1 is 6. Then we multiply the accumulator by what is it? Let me look at my solution. Let's go to LeetCode. Okay. So then we multiply, the accumulator by the current index of nums. So that now it includes the updated product with self included, because we don't want to include self yet, because we don't want the current element included in the product that accumulates across the array. We want only self to count for every element after, not currently. So if we go back to the drawing board, so we have output I is equal to the accumulator times the current output, so it ends up being 6. Then we multiply the accumulator by the element at nums I, which is 4. Now for the next one, 2, we multiply output at the index 2 by 4, our accumulator, which gives us 8. Oh boy. Okay. There we go. So we have 8. There, nice. Okay. So then we do 4 times 3, which gives us 12 for the accumulator. Now next we have, remember the element at nums I here is 2. Keep that in mind. So next we multiply this element of output by the accumulator, which is 12, which gives us 12. Then we multiply the accumulator by the current element of nums, which is 2, which gives us 24. Then we multiply this element in output by the accumulator, which is 24, which this hastily done drawing is actually the correct answer. So basically think of it as the accumulating product across the array from left to right. That's the way to do this in at least 2 times n linear time. So let's share back on LeetCode. Okay. So this is the code for it. So we start with our empty array output. Then we go from the first element, so 0, to the end of the array. Each time we assign output, the current element of output, to the value of the accumulator. Then after we do that, we multiply the accumulator by self, so the current element of nums. So then the next element of output will include that updated product. Then if we go from right to left here to get the product in the opposite direction, then we reassign output at the given element, given index, by the accumulator, and then we multiply the accumulator by self again to update the product for elements that follow. And then we just return output, and let's run some test cases here. Let's throw in some 3, 6, 1, 7, 8. See, as you can see, it works very nicely. There we go. Hope this helped out. Have a good day.